Hi, welcome back to my YouTube channel. If you don't already know, my name is Abdulwahab Animoku and I'm a college math instructor. And in today's video, we're going to look at how to find the equation of the tangent plane and the normal line to the ellipsoid, or the normal line to a surface at a particular point, in this case 2 and 3. Now, how do we solve such kind of problem? How to find the equation of the tangent plane? Now, let's just lay out the formulas that allow us to do this. Okay. Now, the first thing is the equation of the tangent plane is given as this. So, first of all, you need to define your function f, which is basically a function that has to do with the surface, and then you evaluate it at the particular point x, y, z. So let me just put the point x, y, z here, which is this point, referring to this point, right? And then you multiply that with x minus x naught, which would exactly be, so this is y0, x0, y0, z0. So basically at that particular point, p, then plus, you do the same thing, add it to that of y, partial derivatives with respect to y, and then multiply by y minus y naught, plus fz at x0, y0, z0, multiply by what? Z minus z0 equal to 0. So this is how to find the equation of tangent plane. Tangent plane. So you need to remember this formula. Okay. Now, secondly, the equation of the normal line will now then be given as, okay, so will now then be given as x minus this x0 divided by fx equal to y minus y naught fy equal to z minus z naught over fz. Now this is the normal line, right? Okay, now let's quickly apply these formulas to figure out the solution to this problem. So the first thing is to get your f, right? F of x, y, z. So let me increase the intensity of this. Okay, so the next thing is to find f of x, y, z, and which is basically when we write this particular ellipsoid, taking everything to one side, and that will give us 9x squared plus 36y squared plus 4z squared minus 108. So basically, this is your f of x, y, z. All right. Now, so the next step is to find the partial derivatives of this. Now, when you find the partial derivative of this with respect to x, that's going to be 9 times 2, x raised to power 1. So that is 18x. Fy similarly can be found, which is partial derivative with respect to y to be 36 times 2, which is 72y. And fz will just be what? 8z. Okay. Now that you have this, you need to evaluate this. Remember at the point. So what's the point that we are working with? We are working with what? 2, 1, 3. Okay. So just write a point 2, 1, 3. Okay. So we need to evaluate this at 2, 1, 3. Remember that this is just a function of x. So that will just be 18 times 2, which is, so this is 18 times 2, which is it 36? Yeah, I think it's 36. Okay. Now fy of 2, 1, 3, that will just be 72 times 1, which is just 72. And fz at 2, 1, 3 will just be 8 times 3, which is just 24. Now we are ready to find the equation of tangent plane. At that point, so this would give us, remember, we quickly write it again, is this. Z not equal to 0. So fx is just 36, x minus x naught. Remember, this is your x naught, y naught, and z naught, right? So this will give us x minus 2 plus the next one is 72, y minus 1. And finally, we have 24 z minus 3 equal to 0. Now we just need to expand and simplify. But we can just notice that what 12 can go into 36, 72, and 24. So we divide all through by 12. So divide through by 12. That will simplify our work drastically. Or if you like, you can just expand everything out and then simplify and then figure out that later on 12 can go through all these numbers. Now it's left for you to do the algebra. I think it's not hard to figure out. So divide through by 12, 36 divided by 12, that will give us 3. 72 divided by 12, I think that gives us 6. And finally, 24 divided by 12 is 2. Right? Now you can expand, right? So 3 times x is 3x, 3 times minus 2 is minus 6. Then you have plus 6y minus 6. Then you have plus 2z minus 6 equal to 0. So writing everything together now in a very nice way would give us minus 6 minus 6 minus that's minus 18 equal to 0. So this would give us the equation of the tangent plane at that point to the ellipsoid. Okay, now the normal line, which is now quite easy to find, equation of the normal line, remember, is just going to be x minus x naught. So x minus 2 divided by f of x, which is 36, and fx, which is 36, then y minus y1 all over 72, which will be equal to z minus 3 all over 24. Right, so this gives us the equation of what normal line. And that brings us to the end of the video. If you like this video, please click the like button. Also comment below if there's any particular question you would want me to solve on this channel. I'll be more than happy to do that. And then subscribe to the channel to help the growth of this channel. Share in your various social media so that other students like you can benefit from this kind of videos and knowledge. And I will see you guys in the next video.